Okay, this is the 8-1 lesson. We'll do that in class. Find angle measures in polygons. Our learning target, we're going to successfully find the angle measures in all polygons. So the first thing we're going to do is our polygon interior angles theorem. That just means the sum of the measures of the interior angles of a convex n-gon, and we've talked about an n-gon. That just means how many sides, so n is just number of sides. Okay, so in this case the sides are 6. So the formula is n minus 2 times 180, and that really comes from the amount of triangles that are inside the picture. But I'm not going to go through the basis of the theorem. I'm just going to ask you to use the n minus 2 times 180. So in this case, it really just means every angle through the end angle. So 1 angle, 2 angle, all the way to angle 6. You just go n minus 2 times 180. So in this case, this would be an n of 6. Okay, the corollary to that is the sum of the measures of the interior angles of a quadrilateral. And remember again from before, quadrilateral is 4 sides. So if we do 4 minus 2 times 180, the inside of a quadrilateral has to be 360. Okay, if we look at example 1, find the sum of the measures of the interior angles. Okay, the first thing we do is count our angles. So we have 1 angle, 2 angle, 3, 4, 5, and 6. So the angles and the sides are the same number. So there are 6 sides and 6 angles. So to find the sum of the measure of the interior angles, all we do is 6 minus 2 times 180, or 720 degrees. Okay, same thing with this one. It's a little hard to see, so it might be easier to mark your sides instead of your angles, because remember the sides equal the angles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 sides and 10 angles. So we're going to go 10 minus 2 times 180, or 1,440 degrees. So that's the first idea for section 8.1, that if you need to find the measure of the interior angles, you just do n, or count the sides, minus 2 times 180. Okay, so we have an example using that formula. It says the sum of the measures of the interior angles is already known at 1260. So we're going to classify the polygon by the number of sides. So you're going to use your, remember, n minus 2 times 180 equals the sum, but we already know the sum, so we're going to solve n minus 2 times 180 equals 1260. Okay, the easiest way to solve for n is we're going to divide both sides by 180. So n minus 2 is going to equal the 1260 divided by 180, which is 7. We're going to add 2 to both sides. So there are 9 sides and actually 9 angles, which, if you remember from your quick review, is a nonagon. Okay, so again, you're just using your n minus 2 times 180 equals the sum, but you're filling in the sum. Okay, let's take a look at part B of the same thing. Exactly the same type of idea. So n minus 2 times 180 has to equal our total of 1620. Divide both sides by 180. So n minus 2 is equal to 9. So we're going to add 2 to both sides. So the number of sides and the number of angles is 11. There's not a fancy name for 11, so it's just going to be an 11-gon. Okay, we're going to use those ideas to solve some problems using algebra. So if we look at example 3, it says find the value of x. So first of all, we have to know what the sum of the measure of the interior angles is. We can either use our corollary, which said 4 sides were equal to 360, or we can do n minus 2 times 180 to find the sum. So we have 1, 2, 3, 4 sides. 4 minus 2 times 180, so that means the inside of this figure has to equal 360 degrees, and there are 4 angles, so x plus all all three of the other angles. The 135 plus the 112 plus the 71 is 318. That has to equal 360, which is the sum total of all of them. So we subtract 318 from both sides. So our missing angle is 42. So again, you're using that idea from above. K and L we're going to solve for now. They are congruent pieces because they have the same symbols. So I'm going to call them both X. Again, I have to figure out how many sides I have so I can decide what the total inside is. So I have 1, 2, 3, 4, 5 angles or 5 sides. So 5 minus 2 times 180 is going to equal 540. So I take all of the angles, X, plus I add up the 68, plus the 105, plus the 109, which is 282. And I know that all of these angles have to equal 540. Okay, so we end up with 2x plus 282. We're going to subtract the 282. 2x is going to equal 258. Divide by 2. So missing angles are 129 degrees each. Okay, I'll let you take a look at that for a minute, and then I'll do the second page. Okay, we have something called the polygon exterior angle theorem. It says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, always equals 360. So the outside angles of the figure, the 1, the 2, the 3, the 4, and the 5, the outside ones, always equal 360. So we just add up however many there are all the way to n. So if there's 4 sides, 5 sides, 6 sides, it doesn't matter. The outside has to equal 360, and it's always the angle that is a supplementary to the inside angle. Okay, so for example, on example 4, it says find the value of x. We have 1, 2, 3, 4 angles. We know they are exterior angles, so we're going to use our theorem. So we're going to say x plus 89 plus 2x plus 85 has to equal 360. Okay, we can clean that up a little bit. 3x plus 174 equals 360. Subtract 174. So 3x is going to equal 186. Divide it out, and x is going to equal 62. So this angle would be a 62-degree angle. This angle would be a 2 times 62, so a 124. So if you add up 85, 62, 89, and 124, you should get 360. Okay, we're going to go down to example 5. The base of a lamp is in the shape of a regular 15-gon. Remember, that means all the sides and all the angles are congruent. So regular is a vocabulary from before. Okay, so find the measure of each interior angle. Okay, the easiest way to do that is to use a couple of different formulas. The first way to do it, actually I think I'm only going to show you the one way. So if you look at the measure of the interior angles and the exterior angles, the easiest way to do it is find the exterior angle first. So we are going to use a formula that says, remember, the measure of all of the exterior angles equals 360. So if you do 360 divided by n, you will get the measure of one exterior angle. And then this works in reverse. 360 divided by the measure of one exterior angle will always give you the number of sides or the number of angles. So in this case, if we have a 15n, I'm going to do 360 divided by 15. That's going to give me 24 degrees. That is my exterior angle. Okay, and then I'm going to go back up to the picture on top for a minute. So if you look at this picture again, remember I said that the interior angle and the exterior angle are supplementary. So if we are doing an interior and an exterior angle, to find the interior angle, I just have to go 180 minus the 24 that I just found below to get the 156 which is the interior angle. Or, and again I'll show you this, you could do the formula, but you would have to do n minus 2 times 180, which is the sum of the measure of all of them, and then divide that by how many angles you have. So that would be another way of doing that problem. Personally, I think this is the easiest, where you find the exterior angle and then find the interior. Okay, so if we would do it this way, we actually would have, let's see, so 15, take away 2 would be 13 times 180 would be 2340, and then divide by the 15 sides. So we're still going to get 156 degrees. So again, there are two ways to deal with example 5. Okay, I'm going to move it up to example 6. Now we have a convex pentagon. Remember, a pentagon has 5 sides. The exterior angles are 66, 77, 82, and 62. We want to find the fifth angle. So pretty much a pentagon, we know inside, or exterior angles, excuse me, we're dealing with exterior. We know the exterior angles have to equal 360, so pretty much we're going to say fifth vertex plus 66 plus 77 plus 82 plus 62 has to equal 360. If we clean that up, it becomes x plus 287 equals 360. So we subtract the 287. So x, or the last angle, is going to be 253. Seems a little big. Did I make a math mistake? Let's see. 360 minus 287. 73. Okay, sorry, looking at the wrong problem here, I guess. Okay, so we're doing exterior angles, measure of the exterior angle. So, whoops, sorry. I'm going to change that. 360 minus 287 is only 73 degrees. So we have an angle of 66, 77, 82, 62, and 73. If you add all those up, they should equal 360. So let's just check that. 73 plus 66 plus 77 plus 82 plus 62 is 360. Okay, sorry. Alright, last thing, it says find the measure of each interior and exterior angle of a regular nonagon. Okay, first thing we need to remember is a nonagon has 9 sides and 9 angles. And remember, regular means they are all congruent, both sides and angles. So I'm going to do it the same as I did example 5. I'm just going to use my 360 divided by my number of sides to get my 40 degrees, which is my exterior angle. And then the easiest way to find the interior angle, remember they are supplementary, so 180 minus 40 is 140 degrees, which is my interior angle. Okay, we'll do some more examples in class, but that really does cover it.